Today we're going to talk about trigonometric ratios and trigonometry. Trig means triangle. So we're going to see lots of triangles as we work through these. And metric. And the trigonometric ratio is a ratio of lengths of sides of a right triangle in relation to a given angle. So we're going to look at a particular angle, and then we're going to label the sides, and then we can apply our three ratios that we're going to be looking at throughout this unit. The three ratios are sine, cosine, and tangent. And sine, cosine, and tangent deal with right triangles. So hence we're going to have to go backwards a little bit as well and deal with the Pythagorean theorem. That's probably going to pop up when we get there. But before we look at that, let's look at the three ratios, the sine, the cosine, tangent, and I'm going to start with the left triangle over here. So as we take a look at this left triangle here, let's look at side of angle A. So we're going to start and we're going to label our triangles. And first of all, the box. Across from the box is the hypotenuse. I'm going to label it with an H. Then let's go across from angle A. That's our opposite side. And then finally our third side is going to be across from angle B, which is the adjacent side, which I meant to just write A. But just for our purposes here, because we haven't actually talked about what the definition of sine and cosine and tangent are, here, again, across from the box is the hypotenuse, across from angle A is the opposite, and then our third side is the adjacent. And once we have those labeled, then we can figure out what the sine of angle A is. Well, sine is defined as opposite divided by adjacent. So when we look at this, our opposite length is A, and our, sorry, did I say it wrong? Sine is opposite divided by hypotenuse. So we're going to have opposite divided by the hypotenuse. Our length on the hypotenuse is kind of hidden by my word there, but it's C. Cosine. Cosine relates the side adjacent to the hypotenuse. So if we go back and look at our labeled triangle up here, the adjacent length is B, and the hypotenuse is still C. Following that same logic, if we know the definition of tangent, and we'll talk about a mnemonic in a minute to help us remember, but tangent is the opposite divided by the adjacent. So when we look over here, the opposite length in our triangle up here, and specifically we're looking at angle A, the opposite is A, and our adjacent is B. So let me scoot that up so you can see. But label your triangle with respect to the angles. That's really important. Because what else we have in here is we have another angle in our triangle. Again, trig always deals with right triangles. So when we take a look at this triangle to the right up here, this time what we're going to do is we're going to label with respect to angle B. And what doesn't change is across from the right angle is the hypotenuse. And across from angle B is the opposite. And eventually we'll just use H and O and A. But that makes our third side here the adjacent. And when we fill these ratios in, again, ratio is a comparison of two numbers. It also happens to look like a fraction, and it is. The opposite divided by hypotenuse for sine with respect to angle B is B divided by C. Cosine is adjacent divided by hypotenuse. That is A divided by C. And again, the tangent of angle B is opposite divided by adjacent. We've got everything labeled, so opposite divided by adjacent is B divided by A. But here's our mnemonic here. We can use a helpful phrase to help remember all three ratios. It's SOHCAHTOA. And your Algebra 1 teacher conceivably taught this to you already. But what it is sine equals the opposite divided by the hypotenuse. Cosine equals the adjacent divided by the hypotenuse. And tangent equals the opposite over the adjacent. So what is sine of z? Again, find it very helpful to label. Since we're dealing with sine of angle z, this is the angle that we're going to look at. Across from the right angle is still the hypotenuse. And then across from angle z is the opposite, which means that our third side is the adjacent side. And then we set up our ratio. Sine of z equals the opposite divided by the hypotenuse. It's 21 divided by 35. And you can leave it in that form. And actually it doesn't simplify. Oh no, it does. If you simplified it, that is also fine. 7 goes in 21 3 times, 7 goes in there 5 times. That's all you have to do. Label the triangle with respect to the angle that you're working with. And example 2, cosine of angle A. Well, here's angle A, but still, across from the right angle is the hypotenuse. Across from angle A is the opposite. If you need to, draw in a line with an arrow, which means our third side is the adjacent. And now we're going to figure out, well, what does cosine of angle A equal? Well, cosine is the adjacent divided by the hypotenuse. So it's 30 divided by 34. You can leave it in that format. You can simplify that fraction. If you simplify it, it's going to be 15 over 17. Either way. The key to these is, do you know the SOHCAHTOA? The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. On this particular problem here, we're looking at angle C. Across from the right angle is the hypotenuse. Across from angle C is the opposite, which means our third side is the adjacent. And then we need to know that the tangent is opposite divided by adjacent. So this one's going to be 14 divided by 48. And again, we could simplify that fraction if we want to. We don't have to. So your alternative is tangent of C divided by 2, I think it's 7/24. Now, like I alluded to a little while ago, sometimes we need to find a missing side. And with trigonometry, it's always dealing with a right triangle. So on this particular problem here, we have a right triangle. We're missing a length to help us find the cosine of angle A. But we can label already, if we go across from the right angle, that's our hypotenuse. If we go across from angle A, that's our opposite, which means that this other side is the adjacent. And we're going to need the adjacent because cosine is adjacent divided by hypotenuse. So we know part of it, we don't know all of it, but we can use the Pythagorean theorem to find that final side. Remember, Pythagorean theorem is a squared plus b squared equals c squared, but it's also side squared plus side squared equals hypotenuse squared. So it's something like a squared plus 10 squared equals 26 squared. You could do 10 squared plus a squared, it doesn't make any difference. But this is a squared plus 100 equals 576. Use Desmos or your calculator to type it in. Subtract 100 from both sides. And we end up with a squared equals 476. And in order to solve this here, actually I need to go back and check. Is 26 squared 576?
Yeah.
Looks like.
Wait, no, it's
676.
Oh, I don't have it. So then it's 576. Sorry about that. And then we can finish here by taking the square root of both sides. And now I think it'll work out. I don't have my calculator open. Somebody help me out for that one. Thank you. 24. So now we know our third side here. It is 24. And we can fill in our final value here because we want to find, once again, the cosine of angle A. And the cosine of angle A is the adjacent divided by the hypotenuse. And if you prefer, we can simplify that fraction, but you don't have to. So the cosine of angle A is 12/13 if you do simplify that fraction. And lastly, OST question. Probably going to show up. I need to study the OST a little bit more to see how much trigonometry is on there. But it says, in the right triangle below, sine of B is 0.60. And if the area of the triangle cannot be 6, what is the length of side BC? Well, there's a couple ways to do this. So if we go to our calculator, we don't use this button very often, but I think it's 0.6, and you might have to press enter, and then it's alpha y equals, but the button here then is, it might be the 4, fraction to decimal. Let's see if that works. And it does. It gives us 3/5. Desmos as well could convert that. And the thing is, if you use 3/5 in the problem, then your area of your triangle is going to be 6, and that's not going to work for us. So what I did is I converted 0.6 to a fraction. And if you know that 0.6, the 6 is in the tenths column here, we can say that sine of angle B equals 6/10. Don't reduce that fraction. Don't simplify it to the 3/5 on this particular one. And if you don't reduce this, simplify that fraction, we should be good. Well, let's go back over here and let's label our triangle, because it says sine of angle B, so we're looking at this one. Across from the right angle is the hypotenuse. And then, remember that the ratio of sine is opposite divided by hypotenuse. So if we go across from that angle, here's our opposite. We already know the hypotenuse, and in fact, we don't even need to know the adjacent, but we can label it anyway. So if we fill this in, what we know is that the opposite is 6, the adjacent is 10, and now what we do want to know, so it does turn out that we do need to know what the adjacent side is, but we have enough information in our triangle to figure out what the that length is by using the Pythagorean theorem. The Pythagorean theorem means, again, the a squared plus b squared equals c squared. We want to find a, and you can call it a squared, you can call it b squared, it's not going to make any difference. But it's a squared plus 6 squared equals 10 squared. So this is a squared plus 36 equals 100. Subtract 36 from both sides, and we get a squared equals 64. And to figure out what the length of BC is, we'll take the square root of both sides. And we end up with a equals 8. So our length here of BC in the triangle is 8. Key on that problem, don't simplify the fraction.